I think there's a lot of misunderstanding about what it means to achieve zero G. People say zero gravity. I don't like the term because you still are under a gravitational field. It's not zero gravity, it's zero G, and I'll explain why in a second. But recently we had Branson going up to 80 kilometers and experiencing weightlessness. And then we had Jeff Bezos going even higher, past the common line, up to beyond 100 kilometers, experiencing weightlessness. And people seem to think that it's because they went to space that they achieved zero G, which is not true. It has nothing to do with their height, and it's not that they went to space and they got to some magical height where there's suddenly no more gravity. That's not how it works. So let me explain how it works. What they did is very similar to, you probably, or maybe you haven't heard of an analogy. Let's say we go up some arbitrary height above the earth and we create this elevator over here. And so let's say this is, 10 kilometers up, and we have a little rope, and here you are attached to the rope in the elevator. And I drop this elevator, and the elevator is pressurized. You're not going to experience any air resistance or anything inside. And as I drop the elevator, I disengage this rope. You will fall, the elevator will fall, everything will fall at the same rate. At this point, you are experiencing weightlessness because in the elevator's frame of reference, you are weightless. This is falling down, you're falling down at the same rate. So because everything is falling at the same relative rate, there's no net force on you. So in the in the elevator's reference frame, you are weightless, so you experience weightlessness. You can have the same thing if you go on one of these parabolic flights. What happened there? Okay, maybe you've heard of one of these parabolic flights. My camera went a bit strange for a second. Where like a plane will go on this parabolic trajectory. Sometimes I have trouble saying that word. So the plane will go up, up, up. First, it really accelerates up. And because you have this additional acceleration that you add to the normal force being the force of the floor on you, it's the push against gravity, so there'll be like 1.8 Gs on the way up. And then what the plane does, so let's have a little plane here. Here's a plane, not the best looking plane, but you get the idea. It's going up, and a plane will have a few forces. It'll have the force of the weight of the plane, mg, okay, and it will have the force of lift that pulls the plane up. It will have thrust that moves it forward, and it will have air drag. So what the pilots will do is they will make the thrust equal to the drag to get rid of the lift, such that the only force acting on the plane as they enter this parabolic flight path trajectory is weight. So what's happening is in the plane you literally go into a state of free fall. So you're falling in the plane. And in the plane's reference frame, just like the elevator, you're weightless because the plane is falling at the same rate as you. Everything is falling at the same rate. So there's this experience of weightlessness, and it will occur over here down to about here, where the plane will rectify and go into the next parabola. And it's kind of strange, counterintuitive, that you're still going up when the weightlessness occurs, because that's when those forces balance out and there's only weight. You happen to still be going up in the parabola at that point. Okay, and the same thing, this exact same thing, and this parabolic flight happens at a regular altitude. I don't know exactly what the altitude is, but it's certainly not space. And what Branson and Bezos did is just the same thing. It's one of these. It's just a longer parabola at a greater altitude that helped them create the experience of weightlessness, just like one of these plane rides. So even if you go up to the space station, which is 400 kilometers up, okay, they have 80% the gravitational field as Earth. So let's go 400 kilometers up. Here we have the space station. Okay, it's a space station, trust me. There's a module here, and a space station. Okay, and it's going around the Earth at like 27,500 kilometers per hour. And the reason why it's going so fast is because it's falling. It's in free fall. It's falling around the Earth. And to balance out, because there's the centripetal force of gravity pulling this thing down, and to balance out with that force, to stay in orbit, you have to go this fast. So this is how fast it's going, and it's basically just falling around the Earth. So it's in a state of perpetual free fall. That's what orbit is. It's just you falling around another body. And everything is falling, just like the elevator, just like the parabolic trajectory. Everything inside you is falling at the same relative rate, so you experience weightlessness. Okay, it's not because of some magic. You have to go you have to go far away into space to float, to have the 0G of being in space that people think it is. The 0G that you get here, the microgravity that you get in the space station, that you get in these flights, is not because you're far away from the Earth. It's not because of that. So for example, if I took you out of this space station, you would still be going this rate, so you'll still be floating because you have that momentum. But if I were to, without killing you, able to magically stop you from going this rate, from going this speed, okay, but you came out and you stopped, you would fall straight down. Gravity. The space station is 80% as much gravity as the surface of the Earth. It just experiences weightlessness because everything's falling at the same rate. So this is why we experience microgravity in the space station and these flights, billionaire space flights. It's not because you're in deep space. So I hope that clarifies things a little bit.